Sixth grade, happy Friday. We're starting with the big quiz from lesson 105 for today, which goes obviously the quiz back to lesson 104, which you learned yesterday. I'll help you set it up. We'll see how we do. Number 2 says, if 3 marbles are pulled from a bag that have 6 red, 8 blue, and 2 green, what are the chances that all 3 will be blue? Step 1, you need to figure out how many total marbles there are. Add that up. So 6, 8, 14 plus 2 is 16. So I have 16 total marbles. I'm trying to get blue ones. How many are blue? That's 8. So the chance is your new number of blue is and the new number of total. Put that one in your pocket. Think what the new number of blue is and the new number of total, and then you just multiply them. You can reduce some of those if you want to make it easier, guys, as you do that. Number 6, if 3/4 of a certain number is 72, then what is 2/3 of that number? Algebra class, 3/4 of a number is 72. Okay, you know when you're missing with a fraction, you multiply by the reciprocal. So take 72 times 4/3. That's going to give you an answer. Answer number 2 of the circle. Okay, problems with that one, guys, is you can't see that very well. So number 1, this is 45 degrees. Number 2, the length of this line here is 8 inches. So if I want the area of a circle, I do pi, area equals pi r squared. 8 inches is your radius. So stick 8 in, square it, times it by 3.14, you have your answer for 9. 10 says, what is the area of the smaller sector? So I want to know what's the area of this piece of pie right here. Well, guys, 45 degrees is what fraction of a full circle? Well, we know a full circle equals 360. So I would reduce this down, maybe to 1/8, and then take your answer from here and divide it by 8. And that will give you that answer. So I'm going to call this up here answer number 2. You take this and just stick answer 2 in there and do 1/8 of it. Number 11, it says, how long is the major arc? Remember, little guy, minor arc, big guy, major arc. And so now we're just doing the opposite, guys. You already did the work for this. This was 1/8. That tells you the major arc is 7/8. It's 7/8 of what? 7/8 times your circumference. Circumference equals pi times, not radius, guys, but diameter. So make sure you double your 8 up to 16. 16 times pi, and do 7/8 of that. If I was a 6th grader, I would do 7/8 of 16. Get my answer, and then take that answer times pi. That'll avoid you from having to work with decimals until right at the end. Okay, extra credit, you're trying to figure out what a decagon is. So look up how many sides on a decagon, draw that up, you're set. Okay, pause the video so that you can do the quiz. Then I'll be seeing you for the front side. Awesome, welcome back. Let's see how you did with decimals to fractions. Get a little review of this one last time. Remember, percent to decimal left twice. 0.1, 1/10. 0.9, said correctly, 9/10. 0.05, said correctly, 5/100, reduces to 1/20. 0.125, reduces to 1/8. 0.5, reduces to 1/2. 0.25, reduces to 1/4. 0.3, it's repeating, 1/3. 0.2, 1/5. 0.75, 3/4. 0.6, repeating, 2/3. 0.01, 1, I was going to write 1%, sorry, 1/100. 2.5 is 2 1/2. My mental math. We're doing the powers that we just worked on this week. 2 times 2 is 4, times 2 again is 8, times 2 again is 16. Exponent is even, answer will be positive. Letter B, I'm taking it apart. 4 squared is 16. Negative 4 times 2 is negative 8. Now I got to write that correctly. It's not 16, it's 1.6 times 10. Because I switch it to a decimal, add 1. Signs are different, subtract, negative 7. Put the 2W and the 3W together. When I do 2 plus 3, I get 5. Then I divide by 5, get an answer of 12. Convert 9/5 times negative 35 plus 32. 5 goes into 35 7 times. 7 times 9 is 63. But it's negative. I then have to subtract because my signs are different. When I subtract, I get 31. The negative was bigger, so it's negative 31 degrees. E, 200% is the same as multiplying by 2, guys. That's $100. What's 100% more? Well, 100% of 50 is $50. What's $50 more than $50? Same thing, $100. G, 2 triangles are similar if their corresponding sides are, that's been a couple weeks since we did that when I was indirect triangles, like lesson 97, if they are proportional. We've been working with those a lot. Square 10, that's 100, minus 1, 99, divide by 9, 11, times 4, 44, plus 1, 45, divide by 9, 5, times 10, 50, minus 1, 49, square root, 7, times 5, 35, plus 1, 36, square root, 6, divide by 3, 2. They give me blank, 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 divided into 1, 2, 3, gives me an answer of 91 1/2. Okay. 6, there's a few things you can do here. Here's a shortcut I did. I took 91 and I started right at the bottom because I noticed this is a 3-digit one and this is a 2-digit one, and for a 2-digit times 90 to get a 3-digit has to be really small, doesn't it? If I took 90 times 10, that would be 900. If I took 91 times 11, well guys, 91 times 10 is 910. Plus 91 is 1001. Done, problem solved. This has to be 10. So as soon as I have that, guys, it's the only number that'll give me a 3-digit answer. Then I just do the math. Switch this to 0.5, and that would slide it over 1. So I have 915 if this was just a decimal. Okay, now feel free to fill in all your numbers if you want. In other words, 10 goes in there 90 times, subtract it a 1, bring down a 15, goes in there 1 time is 10, gives me a 5, that's a remainder 5, and you have it. But always look for shortcuts. That's what your math book is giving you. They're not just picking random things, guys. They're picking things to say, can you look and have a starting thing to think about to be able to get there? All right, let's get rolling with today's lesson. Today's lesson is surface area of right solids. We've kind of been working at these guys. This is just going to take it to the next level. In other words, we can give you the challenges of, we've been working with these complex shapes and mainly finding their volume. Now we're going to do it and find their surface area, and then we're going to give you a formula for surface area of a sphere. We call that the total area of a surface of a geometric solid is called the surface area of a solid. The block shown has 6 rectangular faces, and we add these 6 faces to find it. So remember, we would pair these numbers. So 3, they did 5 times 6 first. And that would be the area of the top. So you'd also have the area of the bottom. You'd have the area of the front, which is the same as the area of the back. You have the area of the left, which is the same as the area of the right. Remember how we did it? We just paired, we added, and then we doubled. And so that's why we only did it in 3, because you just took it 3 times 2 at the end. Okay, example 1 says, can you do the same thing? Find the surface area of this triangular prism. Dimensions are in centimeters. Back to your quiz. We're ready to work a few examples. So the first thing they gave you guys is this triangle. And I'm going to do it a piece at a time. To find the area of a triangle, I take 3 times 4. 3 times 4 is 12. It's a triangle. You have to cut it in half. So half of 12 is 6. Now that's the triangle in the front. you also have a triangle at the back. So as I draw this thing out, I would have this triangle in the back, guys. And so this is 6 back here, that triangle is 6 back there. Okay, now they gave me 2 more numbers. They gave me this 6 there, and they gave me the 5 here. Okay, now I just need to figure out the area of the rectangle on the bottom. Well, that's 3 by 6, which is 18. I need this rectangle on the back, which would be 4 by 6, which would be 24. I need this rectangle on this diagonal, which would be 5 times 6, which is 30. Now, I'll show you the shortcut in a second, guys, but here's why I like this one. I count 1, 2, 3, so you're going around, you have 1, 2, 3 rectangles, and then 1, 2 triangles. That's a total of 5. 1, 2, 3, 4, 5. I know I have all the sides. Now I just add them together. 6 plus 6 is 12, plus 8 is 20, plus 4 is 24. Carry the 2, 2, 3, 4, 5, 6, 7, 8, and I have 84. We were working with centimeters squared. Okay, here's the shortcut for triangles, guys. And they're going to show you that as we look at this next thing. It says the triangular prism in example 1 has 2 bases, that are the triangles, and 3 what we call lateral faces, which are the rectangles. The total area of lateral faces is called lateral surface area. A quick way to find the lateral surface area of a prism is to multiply the perimeter of the base by the height. So the perimeter is the distance between the bases. So if I were to take my 3 bases, my perimeter of my base, I would do 3 on the bottom, 4 on the side, 5 down there. 3 plus 4 is 7, plus the 5 is 12. Then you take that times your height, which is 6, and got 72. So my lateral surface area was 72. Then you add to it the 2 triangles, 6 and 6, which would give you 84. So the shortcut is this, guys. Instead of doing what I did and finding rectangle 1, rectangle 2, and rectangle 3, you just find the perimeter. 3, 4, 5, 12 times 6 is 72, and if you added these 3 things together, guys, you would get 72. So they're going to try to walk you through that in these next problems to try to say, hey, is this easier and faster for you? If you go, that thing is way too confusing for me, I want to do it piece by piece, by all means do piece by piece, guys, okay? Example 2 says, what is the area of the label on the soup can with the dimensions as shown? So here's example 1, here comes example 2. Example 2, I have my soup can. Okay, the label on the soup can, guys, is the thing around the middle. So what do I need? I need the distance around the can. That's called circumference. So I need diameter times pi. They told me to use 22/7 for pi. That was nice because my diameter is 7. So I cancel my 7s. I'm left with the circumference of 22. What's the height? The height is 10. So 22 times 10 is 220, and I'm working with centimeters squared. They asked me, what's the area of the label? What they could have said is, what is the lateral surface area? That's what I found. Lateral means distance around it. Okay, now B says, what's the total surface area? Well, guys, I figured what goes around the can. I didn't figure the top or the bottom. So now I need to do that. Okay, so to do that, I need area of a circle, which is pi r squared. Hang on, I gotta sign my clipboard up for you, which is pi r squared. Okay, challenge for me, guys. I don't have the radius, I have the diameter. So what I have to do, I have to take 7 and I have to cut it in half. So I'm going to do this way. Some of you would say it's 3.5. I agree, but that doesn't cancel with 22. Now I got to take 7.5 and I got to square it. So that's literally 7.5 times 7.5 again times 22/7. Now, how many circles do I have? Well, I have a circle on the top and I have a circle on the bottom. So I have to take that times 2 circles. All right, let's do some canceling. 7 on the bottom, 7 on the top. 2 on the bottom, 2 on the top. 2 on the bottom goes into 22 11 times. What am I left with? 7 times 11. The area of the 2 circles is 77 square centimeters. What do I have to do? I have to add that to the total lateral. So 220 plus 77, 0 plus 7 is 7, 2 plus 7 is 9, 2 plus nothing is 2. I have 297 centimeters squared. So guys, this is the next level of thinking you have to get into, which is to say, I put a 2 here because I know there's a top circle and a bottom circle. I worked with fractions because I have a fraction for a diameter. If I had 3.14, I'm sorry, I have a fraction for pi. I said diameter. If I had 3.14, then I'd have taken 7.5 and made it 3.5. Decimals, decimals. It's fractions, it's fractions. You got to be able to see those things. Okay, continuing back on with your book. Or at the bottom of the page it says this. We can use the concepts in this lesson to create a formula for surface area. A cube has 6 faces. They're all the same. So if I take S and let S stand for the length of each face, then what is the area of each face? Well, it would be S times S, which is S squared. Therefore, write a formula for the total surface area. Well, the S squared would give me 1. I have 6 of them, so surface area would be 6 times S squared. Might want to have that memorized. A rectangular prism has 6 faces. The top and the bottom are the same. The front and the back are the same. The left and the right are the same. We don't say same in math. We say congruent. Write a formula for that. Well, I would need length times width, and there's 2 of those. I would need length times height, and there's 2 of those. And I would need width times height, and there's 2 of those. And I add them all together. Now notice the letters they use, guys. Same thing we do. Pair it, and pair it. We're just finding different pairs for the 3 different letters. A cylinder has 2 bases and the circles of 1 curved lateral surface. So write a formula for the lateral surface area. Lateral surface area says take your radius. Now we usually say you need diameter. Well, how many radiuses are in a diameter? 2 of them. So that's why they have 2 times r times pi. So this 2 pi r, guys, is your circumference, and then you take it times your height. So you have 2 pi r height. If they gave you the diameter, it would just be pi times diameter times height. How do I find area of a circle? Pi r squared. Why do we put a 2 in front of it? Because there's 1 on top and there's 1 on the bottom. Okay, 6, you obviously can see the answers that you were supposed to come up with because I'm using my teacher's manual. You might want to take the time to write those down into your yellow folder or maybe on a piece of paper. Give yourself what I would call a little cheat sheet to use, because it's easy right now when I read this paragraph to say, oh yeah, sweet. And then in 2 lessons I have to do this. I'm like, I can't remember the formula. So take the time to make sure you have those formulas down to help yourself, because guys, surface area is a lot of math and we want all the helps we can get. Okay, second part of your lesson is this. To calculate the surface area of a sphere, we may first calculate the area of the largest cross-section of the sphere. Slicing a grapefruit in half provides a visual representation of what we call a cross-section of a sphere. So they cut it perfectly in half. This is the cross-section. The circle formed by cutting a grapefruit in half is the cross-section of the spherical grapefruit. The surface area of the entire sphere is 4 times the area of this circle. To find the surface area of a sphere, we calculate the area of its largest cross-section, which would be pi r squared, and then we multiply it by 4, so the surface area of a sphere is 4 pi r squared. So I'm glad some genius figured out that the surface area of a sphere is 4 pi r squared, because guys, all I have to do is remember this little box. And when they ask me to fix it, off I go. A tennis ball has a diameter of 6. Find the surface area of the tennis ball to the nearest square inch. Example 3. My cross section would be 6. My formula is 4 pi r squared. They told me to use 3.14. So guys, step 1, we need radius. So I cut that thing in half and I get 3. In my head, I do everything I can without the decimal. 3 squared, 9. 9 times 4, 36. Now, 3.14 times 36. So 6 times 4, 24, carry the 2. 6 times 1 is 6, plus 2 is 8. 3 times 6 is 18, add a 0. 3 times 4 is 12, carry the 1. 3 plus 1, 4. 3 times 3, 9. 4, 10, 13, 11, 1, 2, 1, 2. And we were working with centimeters, I believe, and surface area would make them square. Okay, so be careful. They gave you a diameter. You got to switch it to radius. And then my other encouragement, work with whole numbers before you do decimals. So some students are like, I got to do pi r squared first. So I'm going to do 9, then times 3.14, then get my answer times 4. That makes you work with decimals twice, guys, and eliminates some of the ability to do it in your head. Last but not least, woo! It says example 4, find the total surface area of this figure and the units are in centimeters. I'll see if I can draw this thing. Okay, so you got something that kind of looks like that, guys. They gave me 1 and 2. They gave me 4. They gave me 4. They gave me a 1 up here. They gave me a 2 here. They gave me a 2 here. They gave me a 2 here. Now, the nice thing they did, guys, is gave me small numbers. The challenge thing with this one is to make sure you're thinking of all the sides. So the first thing I'm going to do is I'm going to try to count. Got this up. 1, 2, 3, 4. Now I'm going to try to draw this little rectangle in the back. That's 5. I also have this shape on the right side, which is 6, and this shape on the left side, which is 7. I also have this bottom guy, which is 8. So I need 8 total shapes. Here I go. 1 times 2 is 2. I'm just going to start a thing over here. This guy right here on the top step is 1 wide, 2 long. I have another 2. This guy going up is still 1 wide, 2 long, and this guy up here, 1 wide, 2 long. Okay, so you see all those? Those things that I colored are all 2's. So I got 4 of those. Now I'm going down this back side. 1 times 4 is 4. I'm going across the bottom. 1 times 4 is 4. So if I add those all up, that was 8. Add those up, that was 8. Now, guys, what I have to do is I have to figure out this step thing on the right, which will also be the same thing as the left. So here's how I did it. The total thing was 4 by 4, which was 16. It's missing 2 by 2, which is 4. It's missing it, I subtract. I'm down to 12. So 12 on the right, 12 on the left. Add them up, 24, 32, 40. Problem solved, 40 centimeters squared. Guys, this is as advanced as it's going to get for us this year, which sounds good, and yet that's advanced, isn't it? To make sure I saw 1, 2, 3, 4, make sure I got the bottom. You know, when you look at that drawing, guys, they're missing half these. They didn't draw this little shade on the bottom because it's on the bottom, you can't see it. They didn't draw this on the back because you can't see that. So that's the big time challenge. Okay, flashing back to my book, guys. I said this is about as advanced as it gets. You know, it's up to your interpretation. This one's not easy either, is it? Piece, 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 piece all over the place. Trapezoids, rectangles, and there's a lot of work to be done with those. And we're going to start adding spheres and, you know, semicircles and things like that into that stuff. So it's getting awesome here at the end. Get excited. Okay, done with half of it. Let's get some problems cranking. Here we go. Number 1, it says 20 billion is how much greater than 900 million? 20 billion has 9 zeros for billion, and I add the 20. 900 million would look like that. They asked me how much greater is it, so I need to subtract. So lots of zeros. Cross out the 19, make it a 10. I'm sorry, cross out the 20, make it a 19, make that a 10. That's a 1, comma, 19. They said write your answer in scientific notation, so my decimal point goes right there. So I have 1.91 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I forgot my 0 right here. Look at that. That's really bad drawing of me. So I have 19 billion. That's 9. That's 10. Number 2, the mean of the following numbers is how much less than the median. Okay, so step 1, I'm going to write these numbers so I can add them together to find the average. I'm going to write them in order, guys. So I have 1.17, I have 1.20, I have 3.10, I have 3.20, and I have 4.28. Step 1, I need to know the median, guys. That's the one in the middle. That's this guy, 3.10. Now I've got to find the average. Add them up. 78 is 15. Carry the 1. 1, 2, 4, 5, 6, 7, 8, 9. 1, 2, 5, 8, 12. 1, 2, 3, 4, 5. I need to take 1295 and divide it by 5. 5 goes into 12 2 times. That's 10. 29. Goes in there 5 times, that's 25, 45, goes in there 9 times. Now I got to figure out the difference, which says take 2.59 and subtract my 3.10. That's a 10, that's a 1. That becomes a 2, that becomes a 10. 10 minus 5 is 5. Decimal straight down, 2 minus 2 is 0. I have 0.51, said correctly 51 hundredths. 3. Please evaluate when A is 10 and B is 8. Nice. They gave me 10 squared minus 8 squared. Now that's 100. That's 64. That gives me 36. The square root of 36 is 6. 6, 8, 10. Right triangle. So that's Pythagorean's theorem, guys. Without telling you it's Pythagorean's theorem. It's Pythagorean's theorem backwards. Number 4, if Tyra is paid at a rate of $8.50 per hour, how much will she earn in 6.5 hours? $8.50. I'm just going to switch that to a decimal so I can do it all in one step. So 5 times 0 is 0, 25, carry the 2, 42, add a 0, 6 times 5, 0, 6 times 0, 0, 6 times 5, 30, carry the 3, 6 times 8, 48, plus 3, 51, add 0, 5, 2, 5, 5, 1, 2, 3, 1, 2, 3. Don't need that 0. She's going to get paid $55.25. A 5-pound bag of flour costs $1.24. What is the cost of 75? Ratio box. 5 costs $1.24. What's 75 going to cost? I look, how did I get from 5 to 75? That's 15. So I'm taking $1.24 times 15. 5 times 4, 20, carry the 2, 10 plus 2 is 12, 5, add a 0, 4, 2, 1, 0, 6, hang on, 2, that's 20, that's 10, that's 12, forgot to carry my 1 there, I wrote a 5, that's a 6, there's an 8, there's a 1. That makes more sense, $18.60. Number 6, the regular price of a dress was $30. The dress was on sale for 25% off. What was the sales price? Lots of times we're going to use a 3x2 with this one. I have original change new. The originals are always 100. The changes we're taking 25%. We're taking it off, so it's down to 75%. The dress was originally $30. So I'm going to cross multiply. 75 times 30. Now, guys, this is 0.75 times 30. I did that so I can put the 0 straight down. 3 times 5 is 15. Carry the 1. 21, 22, 1, 2, 1, 2. So it's on sale for $22.50. 6B. What percent of the regular price was the sales price? This is $22.50. Is what percent? You already did the math. It's 75%. Number 7, the ratio of students to parents at the assembly. I always write 3x2s now. Now guys, it might only end up being a 2x2 depending on what they say, but so often they ask me for the total, so I just write it. If I don't need it, then I leave those blank. The ratio of students to parents was 7 to 3. If the total, oh good thing I did 3x2, number of students and parents was 210, how many parents were at the assembly? Add my ratio to get 10. That's real easy. Chop a 0, multiplying by 21. And I want to know parents. So I'm doing 21 times 3 is 63. So there are 63 parents. Number 8. The original price of a hockey helmet and mask was $60. Brandon bought one on sale for 30% off. What did he pay for the mask? Okay, they kind of make it sound like that's two separate things, but I'm assuming the hockey helmet comes with the mask, right? Okay, so the original change new. The original hockey mask cost $60. Brandon bought one that was 30% off. So the original's always 100. He's down to 70. What did he pay for it? So I'm going to take 70 times 60. Now, guys, that's 0.7. So it's 60 times 0.7. I'm going to take a 0. Boom. Gives me 42, 1 decimal, 1 decimal. He's going to pay $42. So it's just like we did number 6 there. Number 9, Chen and his sister are making a model plane at a 1 to 36 scale. If the length of the actual plane is 60 feet, how many inches long should they make the model? Begin by converting 60 feet to inches. Well, if I'm going to do 60 feet to inches, I'm going to divide by 12, guys, because there are 12 inches in a foot. And I'm not going to do it through division because it's 60 feet long. I'm going to do it by multiplication. So I'm going to take this, I'm going to multiply it because this is how long the actual plane would be. So that's 0 straight down, 12, carry the 1. The actual plane is 720 inches long. Now the ratio goes like this. 1 is to 36, as I don't know is to 720. Now the nice thing about this, guys, is this is divisible. 36 goes into 720 2 times. Goes into 0 0 times. So my model would be 20 inches long. So I almost led you astray by thinking it was division at the beginning. It was not. It was multiplication. And we're set. That gives me a 20. Number 10. Transversal review from this week. Transversal R intersects parallel lines S and T if the measure of each acute angle is 5x. So this guy, I said 5. Did I say 4? It's 4x. And the measure of each obtuse one is 5x. What is the measure of each acute and obtuse angle? Guys, remember, these are forming straight lines. Straight lines add up to 180. So 4x plus 5x equals 180. Kind of goes back and gives you a review of this example algebra we did in mental math. So step 1, add them together. 4x plus 5x is 9x. That still equals 180. Get rid of the 9 by divide. So I divide by 9, goes in there 20 times. 20 is what x equals. X is 20. Now I take this 20 and I just stick it in. 4 times 20 is 80 degrees. 5 times 20 is 100 degrees. And obviously 80 plus 100 is 180 degrees, my straight line. Number 11. It says write equations to solve the problem. What percent of 60 is 3? So I take that, and I got to get rid of the 60 by division, divide by 60. Divide both these by 3. Gives me 1 over 20. Good news, we already did 1 over 20. 1/20th, 5%. Hopefully you have that memorized. Number 11, what fraction is 10% of 4? Awesome. Now guys, they asked for a fraction, so here's what I'm going to do. I'm going to switch 10% to a fraction. So I have 1/10 times 4 over 1. And that goes in there 2, that goes in there 2, 5 times 2/5. There's no swinging around, guys, because it's already on the equal side. Number 13, 12 less than twice what number is 86? So this is the practice from earlier this week where we got to translate. 12 less means subtract 12. But I'm subtracting 12 from twice some number is 86. Now that I have it set up, now it's the algebra we've been working on. The challenge on the end of this week is translating that. Opposite of subtract, 12. Do on the left, do on the right. Cancels on the left. 98 on the right. Divide by 2 on the left, divide by 2 on the right. 98 divided by 2 is 49. And I was going to draw the division problem for you that I did in my head, and I probably shouldn't have did it in my head because I like to show work. That's 4, that's 8, that's 18, that's 9. So there's the work behind it, 49. Number 14, the coordinates of the vertices of a right triangle are this, 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 and this. Find the length of the hypotenuse of this triangle. So I have -2 and -2. I have -2 and +2. And I have +1 and -2. So there goes this and this, guys. So I went up 1, 2, 3, 4. I went over 1, 2, 3. They say, what's this length? I have a 3, 4, 5 right triangle. It's in a coordinate plane, so it is units. If you don't remember that, this is a Pythagorean theorem problem. 3 squared 9, 4 squared 16. 9 plus 16 is 25, square root of it, 5. 15, a cubed to a squared. And a is cubed, I'm comparing it to a squared, and they said a has to be negative. So guys, I stuck in -1. -1 times -1 times -1 is 1. 1 times 1 is 1. If it's odd, it's negative. If it's even, it's positive. What's bigger? Positive is always bigger than negative, so negative is less than positive. Picking any number you want, guys, what they're teaching you is this is going to be negative on the left and positive on the right because of our new exponent rules we learned Wednesday, if I remember. Cruising on, halfway done. Number 16. Carmela has a deck of 26 alphabetical cards. She mixes the cards, places them face down on the table, then turns them over one at a time. What is the probability that the first 2 cards she turns over are vowel cards? Well, I have 26 total cards, and I know there's 5 vowels in the alphabet. That's card 1. Card 2 that she's turning over next, I already turned 1 over, guys. So I'm down to 4 and 25 cards. Now to find that, I have to multiply. So I'm going to cancel 5, goes in there 5 times. Divide by 2 is 2. Divide by 2 is 13. 1 times 2 on the top is 2. That's a 15. Carry the 1. 5 times 1 is 5, plus 1 is 6. Chance of her doing that will happen 2 out of every 65 times she tries. Number 17, Alejandro bounced the ball with a diameter of 20 inches. Using 3.14, find the surface area. Remember, surface area from today's lesson is 4 pi r squared. I got 4 times. They told me to use 3.14 times. They gave me 20 as the diameter, guys. That needs to switch to radius, which is 10, and I have to square it, which is 10 again. Okay, now I told you, man, I always multiply these things, the whole numbers first, and then mess with the decimal. You certainly can, but what I'm going to do is I'm going to do this little guy right here. 4 times 3.14. Some of you might have it memorized as 12.56, and then 0, 0, 1, 2. So I think it's easier to do 4 times that than 400 times that. In the end, guys, if it was 400, you'd just slop those 2 zeros down anyways. Your 1, 2 would have taken you to there. So anyway you look at it, you get the same answer. You figure out whatever approach comes easiest for you to get those. 18, write your product in scientific notation. Step 1, grab my numbers. 3.2 times 8. That gives me a 16. That gives me a 25. I have 25.6. Step 2, look at my exponents. Signs are the same. It's a negative 14 as I add them together. Can't have 25, needs to be 2.56 times 10. Because I switched it to 2.56, I add 1. Signs are different, subtract. Gives me 13. Negative because the negative is bigger. 19, find the perimeter of the figure at the right. Woo! They gave me 5, they gave me 30, and they told me the radius is 10. Okay, step 1, guys, I'm going to figure out the perimeter of doing some work here. So if it's 5 on the right, it's 5 on the left. If it's 10 going at a diagonal, guys, this side is 10 and that side is 10. So 10 plus 10 plus 10 gives me 30 here, which equals the 30 on the bottom. Now, 5, 35, 40, 50. So my area from my perimeter from here to here is 50. Now I have to figure out circumference. Circumference is diameter times pi, but it's cut in half. So guys, I'm just going to take my radius, 10. They told me to use 3.14, so 10 times 3.14 slides that decimal over 1, which would be 31.4. Add it together, 418. So I have 81.4, and in this case I'm working with meters. So hopefully you see how I did that. Normally circumference is diameter times pi, but because we only have a semicircle, I'd have to cut it in half, so I just did this. I cut the diameter in half. The whole thing would have been 20. I went down to 10. Number 20, it says find the missing numbers in the table. They gave me 3 and negative 2 and 0, and my formula is y equals negative 2 times x minus 1. So step 1, 3 times 2 is 6. Signs are different, it's negative 6. Negative 6, negative 1, signs are the same, add together, get negative 7. Negative 2. 2 times 2 is 4. Signs are the same. That would be positive 4. 4 minus 1 is 3. 0 times who cares is 0. 0 minus 1 is negative 1. It says then please graph the coordinates, the function on the coordinate plane. I have 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7, 3, negative 7. I have negative 2 and up 3, and I have 1 and negative 1. And those 3 dots form a straight line. Number 21, find the volume and then the surface area. Okay, to find the volume, guys, it's length times width times height. 5 times 5 is 25, times 5 again, almost messed up, C box. This was 125, I'm working with millimeters, that would be cubed. If you remember the formula today, I would have taken 6 times side squared. So 5 squared is 25. 25 times 6 is 150 millimeters squared. Number 13, find the volume of the right cylinder. They want volume, guys. That is not today's lesson. Today's lesson was surface area. We'll probably get there in a second. So I want volume. I need area of a circle, which is 10, pi r squared, so 10 squared is 100. 100 times 3.14 slides 1, 2, so it's 314. Times my height of 10 adds another 0 onto the end of it. So the nice thing, guys, is they gave you 10s. 10s are nice to work with. 3,140 centimeters squared. Number 23 says the total surface area of the cylinder included the area of the 2 circles and the curved sides. What's the total surface area? So I'm back here, guys. I'm finding the area of a circle. I did the math for that. It was 314. If it's 314 on the top, it's 314 on the bottom. Now what I need to do is I need to find the circumference. So that's not 10, guys, that's 20. 20 times pi, so I need to do 3.14 times 20. That's 8, that's 2, that's 6, 1, 2, 1, 2 is 62.8 times the height, which is 10. So slide that decimal back. So I have 628. Now what's interesting, guys, is if you take the two circles, you're going to get 628. So the top, 314, the bottom, 314. When you add the top and the bottom, you get 628. When you go around the middle, you also get 628. Interesting little rule when it comes to circles with 10. Then I add that together. I get 16, carry the 1, that's a 5, that's a 12. So I have 1,256. This would be centimeters squared. I labeled that one wrong. That should have been centimeters cubed. 24. Find B, the measure at the right, and explain how you found them all. Okay, they gave me 30, and then they gave me A here. And then they went through this line like this, and then they went through this line like that, and my drawing is not good because they said that's a right angle too. My job is to get all the way over here to B. So guys, it looks like this. 30 plus 90 is 120. 180 minus 120 is 60. So this guy is 60 here. If it's 60 on the left, it's 60 on the right. 60 plus 90 is 150. Subtract 180 from it, and you're down to 30. Okay. 24 said, what's the measure? It's 30. Then explain how you did it. I'm going to write C box. I look here, I see exactly how you did it. True or false? These two triangles are similar. True. They are both 30, 60, 90s, 30, 60, 90s. Congruent? I would say no. One looks smaller, but they definitely are similar. Turn the old page in the book, 25. The triangles shown are similar. Estimate, then calculate x. So I got triangle number 1, which is 6 and 12. I got triangle number 2, which is x and 8. So how do I get from 8 to 12 is the same way I get from x to 6. If we want to do that in the ratio box, it just simply looks like this, guys. 6 goes with 12 as x goes with 8. I'm going to do with cross multiplication. 6 times 8 is 48, divided by 12 is 4. Some of you might have reduced this to 1/2. 2 times 4 gave me 8. 1 times 4 gives me 4. So for A, I got there by, my answer is 4. B says, what's the scale factor? How did I get from 4 to 6? 4 times, I don't know, equals 6. Missing something in multiplication, I divide. Divide by 4 on the left, divide by 4 on the right. Okay? Some of you might reduce that down to 3 over 2. You can't leave it at 3 over 2, guys. Remember, scale factor is always a decimal, so it's 1.5. C says, the area of the larger triangle is how many times the area of the smaller triangle? Now I'm going area. Area is squared, so I take 1.5 and I square it. Look at my wall. 15 squared is 225. So I write down 225, 2 decimal places, 2 decimal places. Similar triangle formulas. 26, 4 1/2 x plus 4 equals 48 minus x. Okay, guys, we got to get these problems to the letters to the one side, numbers to the other. I'm going to subtract 4 on the left, I'm going to subtract 4 on the right. On the left, they cancel. On the right, I'm down to 44. I'm going to get rid of minus x by adding x. Add on the left, add on the right. What number am I bringing? It's a 1. Those cancel. So now I add 1 to 4 and I get 5 1/2 x equals 44. I'm going to make it improper. That's 11 over 2 equals 44. Stay, change, flip. Cancels. 11 goes into 44 4 times. 4 times 2 is 8. Number 27. I have 3.9 over 75 equals C over 25. How did I go downhill? I divided by 3. So I divide by 3. 1, 3. Okay, hopefully you can see that. Just make sure you understand you're going down, so it's division. 28. I'm going to start with those numbers. I'm going to work with fractions, guys. So I'm going to make 2.5, 5 over 2, divided by 8/5 is stay, change, flip. I said 8/5 because I flipped it already in my head. Cancel, 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 4. Now I'm going to take 3.2 and divide it by 4. 4 goes in there 0, 4 goes into 32, 8. So in the end I went back to a decimal answer because this came out as a whole number. 29, 2x, y, in parentheses, times 4x squared, y, in parentheses, all being divided by 8x squared, y. Some of you might multiply first, some of you might cancel. I'm going to do the canceling game. 2 goes into 8 4 times, 4 goes into 4 4 times. I got an x squared here, I got an x squared there. I got a y here, picking y you want, I'm going to pick a y there. What am I left with? Xy. So that's just fun stuff, guys. It just cancels things out, makes me feel good. Problem, I wrote way too big, so now I can't fit 29b in there. Here we go. 3x plus 3 minus the square root of 9x squared. So 3 times x, 3x, 3 times 3 is 9, minus the square root of 9 is 3, and squares and cancels cancel, so I got 3x. Now you put things together, 3x minus 3x. 3x minus 3x cancels, it's 0. What am I left with? The 9. Okay, so guys, so many of these problems look so intimidating, and in 6th grade, we cancel almost everything out to get nicer, smaller answers. And 30. I have negative 10 times negative 4. Gives me positive 40. Signs are the same, answer will be positive. Minus 3 times negative 2 times negative 1. 3 times 2 times 1 is 6. 2 negatives make up positive. So I have positive 6. 40 minus positive 6 is 34. Okay, that's only halfway done, guys, because that was just the top. Now the bottom is negative 4 minus negative 2. Add the opposite. Signs are different. I subtract. I get 2. Negative is bigger, so it's negative 2. Negative 2. Divide. 34 by 2 is 17. Signs are different. Answer will be negative. And B, I have negative 2 to the 4th power minus negative 2 to the 2nd power plus 2 to the 0 power. 2 times 2, 4. Times 2 again, 8. Times 2 for the 4th time is 16. It's even, it's positive. Minus 2 squared is 4. It's even, it's positive. Plus, any number with the 0 power is 1. Left to right. 16 minus 4 is 12 plus 1 is 13. Awesome. Knock that thing out, guys. Lesson 105 done. Extra credit for the day. On the top of your page, from today you're figuring out how to find surface area. I want you to write for me the formula for the surface area of a sphere. So at the top of your page, 4 pi r squared is the surface area of a sphere. Have a great weekend.
is the next game, question mark?